a couple virtual students in Algebra that they could not hear me in the videos at all because I stand in the back of the classroom. Would anyone echo that?
Yeah, it's hard to do. Like if you turn your volume,
They said they turned it all the way up and went like this. Yeah. So I'm going to try to stay more towards the front just so that they can hear. The microphone. What microphone? What does? What does that do?
You should have like a microphone. Yeah.
One of the necklaces?
Yeah, the necklace.
They still have those?
Yeah.
Still uses it.
Oh, I totally would have used that because then they would be able to hear me and I could move around.
Or you can just carry your iPad everywhere.
That's what I'm doing. That's what I do. But the sound is at my computer. All right, I got to write that down. Microphone necklace.
Yeah, because you have that in your classroom yet you never use it.
Yeah, I don't have the little black microphone things with the cool magnet. Yeah, I don't have one of those. Okay. Anyway, until I get one of those, I will be staying up here. Up in this area. Today we are looking at day 9 and 10. We do not have a warm-up. Our learning targets is that we are still working to graph these rational equations, just like what we've seen the last couple of days, except this time we are going to have an x involved in our, that's not a good color, x involved in our numerator, okay? Up to this point, we have had them look like this, right? Our numerator has just been some constant. It's just been some number. That was on accident, but yes, the last problem. That's why I said just type something random in and hit submit. But maybe you tried it, and that works great too. But today, we're going to figure out how to do that last problem on the big ideas. The ones we are looking at today, again, will have some type of x in the numerator, and we're going to see how that changes things. Honestly, it really doesn't change a whole lot. The only thing it will change is how we find the y asymptote in our graph. So I'll go through these two bullet points kind of word for word, and then we'll look at some examples. In the past, we have found the x asymptote by looking at the denominator and seeing, okay, what can x not equal? What would make this 0, right? And we're going to do the same thing now. We're going to see what makes the denominator 0, just like we have in the past. Nothing is changing there, and that will give us the x asymptote. Now to find the y asymptote, this is where things are a little bit different. To find the y asymptote, we are going to look at whatever value is attached to x in the numerator and divide it by whatever value is attached to x in the denominator. So a divided by c will give us the y asymptote. That's the only difference today, right here. We're going to have to do something to find the y asymptote. So if we look at this first example, what is our x asymptote? Oh, I lost count. 1, 2, 3, 4, 5, 6. Exactly. Now, if we look at the number attached to x in the numerator, denominator would just be 1 over 1. So our y asymptote is just positive 1. Perfect. Like y? Why does that work? You're confused already? Are you confused on like what you're supposed to do or just why that works? So to find our, you know how to find the x asymptote, right? We look at the bottom, what can x not equal?
Oh,
Okay? To find the y asymptote, we take our a value and divide it by our c value. Whoops. Which I know we haven't looked at these equations like in this form. We've never seen this outline for it or this formula for it because it hasn't been useful, but hopefully we can see.
the A and C are 1.
In this case, yes, the a and c are 1. So that means our y-intercept is just positive 1. Or our y asymptote. Now, on these questions, we have sketched graphs. We've labeled our asymptotes. What missing piece that we did yesterday do we still have to find? We have to find our intercepts. So we are going to do the same type of thing to find our intercepts. How do we find our x-intercept? What does y have to equal? Y has to equal 0. Y has to equal 0. So what we have talked about in the past is we set it equal to 0. 0 is the same thing as 0 over 1. And then we look to cross multiply. 0 times all of this is just going to be 0. Now we have 0 equals 1 times x minus 4. Right? The 1 really doesn't do anything. So x equals positive 4. That would be our x-intercept. Now to find our y-intercept, it's really easy. What does x have to equal? Yep, for our y-intercept, right, where it crosses the y-axis, x has to equal 0. So if we put 0 in, oops, no. We get negative 2/3. So now we want to plot our intercepts to help us see where those graphs are supposed to go. Our x-intercept, or where it crosses the x-axis, is positive 4. Our y-intercept is at negative 2/3. So we can, and like I've said in the past, I'm not overly picky on on how like good your curve looks, or anything like that. But I will be obviously picky on where you put your asymptotes, what your intercepts are. Those things. I mean, there's only really one option for those. In our graphs, we need to make sure that they are opposite of each other. Right, because we just have, I don't think we will be dealing with any x squares, if I remember right. Yep, all of them will be opposite. There's no x squared, x cubed. Yeah, Kaylee? This one? So we know, remember our parent function, I'll write it in a different color, is y equals 1 over x, right? That's our parent function, and that looks like this. So they're opposite, they're kitty corner, they're diagonal. And even though we have an x on top with this one, it is just an adjustment to this parent function. So we are still staying opposite of each other. Now, if you want to make sure that you're on the right track and they're staying opposite, throw this original in your y equals. And even though it might be tough to see the intercepts or tough to see your asymptotes, at the very least, you'll be able to see in your y equals that those graphs are opposite of what quadrant those are in. What questions do you guys have on that first one? Oh, this is number 1 on your page, by the way. I'm doing your homework for you. I'm gonna do number 1, 2, and 3.
Are you recording this?
I am recording this. Yeah, thank you.
Sure.
Positive. We're 9 minutes in. Questions on that first one? Number 2. Our x asymptote is going to be 1, 2, 3, 4, 5, 6 here. And then remember, we find the y by going a over c. Our a value is 2. Our c value is 1. Yep, that's how, I mean, you guys can start these problems out however you want. Like for me, if I'm doing this, the first thing I'm doing is figuring out what those asymptotes are, figuring out what my intercepts are, and then I'll be able to sketch my graph in. Probably is the most logical way to go through these. Now we want to find our intercepts. To find our x-intercept, again, y has to equal 0. We write that as 0 over 1. And eventually, I mean, I'm going to show all the work for it, but eventually when you're finding these x-intercepts, you're going to understand really quickly that you're just solving the numerator, right? Because we have 0 times x minus 6, 1 times 2x plus 5. So really, to find this x-intercept, we will just be solving, putting the numerator equal to 0. But if you want to set up, and a lot of times I will too, set up your original equation here, cross multiply and do all that, then that's a good way to make sure. If we solve for x, we'd get negative 5/2. Now our y-intercept is a lot nicer. We put 0 in for x and solve for y. So these would cancel out. We have nothing there. So we would have 5 over negative 6, or negative 5/6. Remember, these intercepts are points on our graph, right? When our x-intercept is negative 5/2, comma 0 would be that point on the graph. Our y-intercept is 0, comma negative 5/6. So even though we just write them as x equals a certain number, y equals a certain number, we need to remember that they're points on our graph. Just the other one has to equal 0. So when we plot these, x is negative 2.5. Y is almost 1, almost negative 1. That does not look good. That doesn't look good either. I heard somebody just laugh. That's okay. I can take it. But it would look something like that. Right? My intercepts are correct. My asymptotes are correct. My sketching of this graph looks average. So, but you guys get the idea. Questions on that one? That's number 2. All right, why don't you guys try number 3 on your own, and I will put some pieces up at a time, and then that's it for today. Then I'm letting you loose to work on the rest of that page. Well, front and back. Why? No. Put it in the basket. That's late. Put it in the basket back there. Mr. Late McLake, late. Third one. That one. No, far one. No, third. There we go. We read left to right. We read the baskets left to right. So first hour, second hour, third hour. That wouldn't make a difference. Oh, that's a good drawing right there. Just wait till I unfreeze this screen. You guys ready? Or sorry, do you need another minute to finish up? Okay, give it another 30 seconds. Just really excited about how good this one looks. How many of you guys that turned your review in on time already graded it? Did most of you? So like I said yesterday, would it be beneficial to look through this together, or you already did on your own? Okay. Then I will throw these in, and you'll just have the rest of the hour to work on stuff. I'm coming over for dinner tonight. I'm going to tell Mom that you handed your assignment in late. Hey, late is late. You just put 2 + 6 = 8 on that last one, too.
No,
Yeah, I know. Yeah. What did I put? 7 + 4 = 11? That's more like it. Yeah, well, that's what our last one should look like.
Dude, I'm not done.
Hey, well, you've got 1, 2, 3, 4, 5, 6, 7. Yeah, only 8 problems.
You're gonna have to go through
8 problems in 40 plus minutes. I think we can handle that. I will be honest, these do take some time, though. Like, to find the intercepts to do all that takes some time. Yes, Faith? Did I do this one wrong? I didn't do this wrong. Oh, sorry. That would be, yes. Then you get really good. Yep. There's a couple of them that are like that. You have a question on this one or a different one? Okay, I'm going to stop recording. Are there any questions on this one before I stop recording? Because the virtual students might have the same question as you.